Okay, so we've modeled a number of elements of our go-kart and we've used subDs to do so. What I'm going to show you in the next few chapters is how we can improve certain elements and also optimize them using a small selection of tools. So the first thing I'm going to show you is that we don't have to stop, for instance, with something that we've modeled in splines. If we look at the steering wheel here, you can see that it's actually relatively smooth going all the way around. What we could do here is maybe add some more detail. So to do that, I would, let's say, go in here, add an edit poly modifier. And now I would, let's say, go in here, select this. Let me just turn on ignore back facing, otherwise we're just going to select the back edges. So select this edge here, which you can see is the point where this surface changes from, say, leather into metal. We'll go around the other side and we'll do the same thing. Hold down Control, do a loop selection and use the split tool. And that now breaks those edges apart, so we have two sets of edges there. The reason for that is now I can select this edge and I can do a ring selection. And because it's broken at this point, let me just use a shared pivot here. You can see that it actually stops the ring selection here, which is key for what I want to do next. What I want to do next is just select alternate edges here. So let me just go here and select, hold down Control, select. So I'm just selecting alternate edges. So I just want to create some detail by doing so. So I'm just going to go around here. Select these edges as I go around. There are actually tools which allow you to do this much better. There's a suite of tools which I believe is called Polyboost, and also there's Orion Flame, and these are commercial sets of scripts basically that are designed for subD modeling, but they allow you to do things like select alternate selections of edges, faces, and much more. So definitely worth looking at once you get into subD modeling. So now I have all of these selections. I can just say ring, select those. I want to change that into a face selection, so hold down Control, click on polygons, and now I just want to extrude this out slightly. So I'm just going to say bevel, and just do, let's say, a very small amount. See here, just up slightly, and then inward slightly. Let's just keep this very small. Well, keep that very small as well. We just want a slight extra little piece of detail here. I'm going to try local normal, if that's any better. Looks like it might be. We don't want to do it too much, actually. Let's just bring that back down again. Have it go in a little bit more. I think that looks okay. Just okay that. And then we can put also turbo smooth on top. We can actually smooth this a little bit more. Let's just say turbo smooth. And you can see now that if I just turn on isoline display, we've got some nice sort of ridges going around here, which give it a slightly more interesting look. Slightly ridged as it goes around there. Pretty cool. I've done the same thing to this element here. I've actually put an edit poly modifier on. And in the original model, there wasn't any beveling here. So I've just basically used edit poly to go in there, select some faces, extrude them outwards and bevel them and so on, and just add some extra detail to that element there. So you can see it'll shade a little bit better render time. We could do exactly the same thing to all of these elements. We can just go in here, just put an edit poly modifier on. It's very quick and easy to do. Go into face mode, turn on by angle, select the face, and it'll select all the other faces because they're within the same angle threshold. Hold down Control, do the same here. And now I can just say bevel, let's just go up a little bit and inward slightly. Just try out local normal, see if it gives you a better result. In this case, it doesn't really make any difference. Let's just make that a little bit more subtle. So look at that. Yeah, that looks pretty cool. We can just okay that. And now we've got a nice little bevel on there just by using the edit poly tool. So it's a good practice to, bear in mind that whenever you model something, if it's a spline based element, if it's a primitive, whatever, basically you can change it into another type. You can add on to it using subds. You don't have to limit your models to one type of geometry. They should be able to easily flow from one into the other. You know, you should be able to take a spline-based element like this lathe that you have here and just work on top of it using edit poly. You could take these if you wanted to, these loft elements here, and actually change those quite easily just by applying the edit poly modifier and working away, you know, doing extrusions and adding more details and so on. It's as simple as that. You know, you can just flexibly move and add detail on just by using edit poly modifiers. Let's have a look at another issue here. Let me just show you some of the geometry that we modeled earlier on in the previous few chapters. If you look at these pieces of geometry, you can see one of the issues is that they're just one-sided. They're also infinitely thin. They're just literally just single-sided polygons. So when you're modeling with subds in the way that I did using planes, you're going to get geometry like this where you can see through it, and it's infinitely thin, which is obviously completely unrealistic. The way that I get around this is by using a modifier called the shell modifier, and it's actually perfect for adding any kind of thickness that you need to have on models produced in this way. You can also use it on other model types, things like lathes, lofts, and so on. So it's not just limited to a subd workflow. So let me just show you how it works. It's very easy to understand. It basically adds some thickness to an object based on its z direction of its normals. So if I select this object here, we'll just turn off Turbo Smooth for now. And we want to apply this modifier, let's say, before the symmetry, I would say, because we want to basically apply it to the simplest version of the geometry. So we'll apply it before it's actually been symmetried. So we'll go down here, find shell, apply it, and I think you can see what it's actually done. So if I just show you, you've got an inner amount, which adds geometry in that direction, and you've got an outer amount, which does it in the other direction. Usually I just stick to one or the other, whichever makes the most sense. So inner maybe makes more sense in this case. It'll actually obviously keep the outer shell the same, and it'll just add some thickness inwards. So it's great basically extruding all of these polygons inwards, as you can see here. Now if we show the end result, we'll turn on this. You can see that if I just turn off the shell, as before it didn't have any interior faces and it basically had no thickness, and after we use the shell it does. So it's pretty stark what it does there. You know, it's such a fantastic little modifier. So let me just show you here again what it's doing. Now by default it'll have just the one segment, but if you're finding, for instance, that let's say you make a bigger distance and you're finding this is too round, you can actually make this harder, but just by putting in more segments here. So you can see you get more definition across here. If I just turn off end result, you can see that it's just adding some more segments along the direction of the extrusion basically. And it has a number of other options which you can check out down here, and it has the ability to add different material IDs to the edges, to the interior faces, the exterior faces, and so on. So it's a really, really cool modifier. So let's just apply it to a few more elements. I don't want these to be quite as thick, so let me just change that to 0.3. And let's just show the end result, see if that looks nice. Maybe it's a little bit too thin. Let's try 0.5 to make it a little bit more robust. We'll keep the poly count down by just having 2 segments. I think this looks pretty cool. We'll just copy this, and let's just go back here. We'll just try pasting that modifier as an instance. And that means now that if I change the parameters on this modifier, it'll change the parameters here also. So that's a pretty efficient way of optimizing any changes. So watch now. If I do 1, type that in there, you can see it gets thick at the front and the back because they're basically sharing the same modifier, as you can see. So that's a really quick way to keep all your shells synchronized. Now, it may be that the thickness of the shell that I want here and on here really wouldn't make sense. Maybe we want the seat to look a little bit more robust. So I'll just go and I'll copy this instead of, we'll just paste it rather than being instantiated. We're getting some problems here. You can see down the model middle, we're getting some issues with the geometry. So let's try and work out what's going on here. So I'm guessing that it's not actually welding with the symmetry. So what we could do is, let's just get this and put it after the symmetry modifier. So after the weld takes place, because if you look in the symmetry modifier, it not only mirrors your object, but it also welds along the seam. So it's welding along here. And basically our shell modifier beforehand was actually extruding with these vertices unwelded. So that meant that, you know, after being subdued, it basically looks like a mess. So we just need to put this after the symmetry. So it takes place after the weld has taken place. At the moment, it looks a little bit flimsy, as you can see, especially down here. So we just want to make this a little bit more robust by popping this up to, say, 1.5. There we are. So we've given it some thickness, and we can just make it a little bit more hard-edged just by putting in some more segments. And we'll do the same thing. We'll just, you know, another way you can actually move modifiers around is by dragging and dropping them. So we'll just do that, drag that on there. There we are. So we now dragged it onto the hood. And as you can see, now the hood has some thickness. Looks extremely thick at the moment. So let me just change the size of that to, say, 0.75. And we'll just decrease the number of segments. Oops. We're looking a little bit strange there, so let's just put that back. And we'll put it on before the turbo smooth. That's an important thing. And we want it probably after the symmetry modifier. Otherwise, we'll have the same issue as we had on the seat there. So this has actually made quite a big change to this bonnet. I don't think you actually probably saw it when I applied it, but let me just turn off the shell modifier. That's it before and then after. So you can see it gives you some much nicer form in here. Actually, we've got some thickness to it now. You know, it looks much more realistic. Let's just make it actually a little bit thicker again. There we go. Looks a little bit more robust now. So yeah, there we go. We've added some more detail onto the steering wheel here just by popping an edit poly modifier on top, making some judicious selections, extending those selections by using the ring selection tool, and then converting to edit poly and then extruding those poly selections outwards. And we've added thickness to all of the plane-based flat geometry that we created earlier by just extruding out edges. So we've actually given our go-kart much more form and realism just by doing some quite simple changes there. Okay, let's move on into the next chapter and we'll have a look at a couple of more tips and tricks.